John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporland's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a balanced port TEV.
Well, come on, I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea.
Indeed.
These easy to select and assemble valves mean you're always carrying the right valve for the right job then. If folks want to learn more, what do they do?
You can go to sporland.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporland signing off.
We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporland, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
Hello, everybody, and welcome to Advanced Refrigeration Podcast. You're here with the host, Brett Wetzel and Kevin Compass. We also have a special guest tonight, Donald Felice. Donald is going to break down VRF for us because, we know the principles on VRF, but we just don't know how it's running. How's your week going, Donald?
It's pretty good. Wrapped up a job today that has taken about 4 months to get started up on, so it feels pretty good. 4
months?
Yeah, there's been a lot of delays.
You don't say. Parts, right?
No. We've been delayed by a controls vendor for about 2 months, and then parts is about a month.
Nice. So like I said, Donald's going to join us tonight and going to talk about VRF. We're going to just ask him a shit ton of questions because, like I said, we have a general idea on how the stuff works, but I mean, he's going to set us right in some of the things we think how it works. Don, you want to start off telling us, where you work at, where you've been there, how long you've been in the industry and stuff like that?
Sure. So my name is Donald Felice. I'm currently living in Northern Bay Area, California. I work for Norman S. Wright, which is a product rep firm. I'm head of the technical services for VRV and other Daikin equipment. That's what we specialize as Daikin, but we have a broad range of other products. I've been doing this for 8 years. I came out here in 2015. My dad offered me a job, and it was right place, right time. I was a auto mechanic and just going nowhere. So switched it up and haven't looked back.
So you've been predominantly working on like controls and HVAC, or?
Yep. So, you know, my dad, my background is he's kind of always had this stuff around the house, and I've told him I don't want to do it. You know, I never wanted to do that. And then he made me an offer, and it's been incredible.
Okay, Dad.
Yeah. Yeah. So for many years, I told him I never wanted to be an HVAC guy, and here I am taking the reins.
That's awesome. That's awesome, man. I guess just get into it. You know, if you want to do an intro on, we'll talk about a little bit about 2-pipe system and 3-pipe system. So start off where you're comfortable, and we'll go from there.
Sure. When I jump into a training for anybody, I always tell people to remember the basics. At the gist of the system, it's still refrigeration. It's still the refrigerant cycle. There's nothing crazy. We're just varying compressor speed and using the indoor coils as evaporators or condensers as needed. So that's kind of the big difference versus a conventional air conditioning system and a VRF system is what component is doing what. So my background is preliminarily in Daikin, but all VRF is kind of the same concept. We have a condenser or an outdoor unit somewhere located outside the building, could be in the building if we got a water cooled unit. We can kind of think that as the central plant. From there, we use the compressor to send refrigerant around the building or bring it back. Daikin's 2-pipe versus 3-pipe. 3-pipe is what we call heat recovery, which is going to be your dual mode system, simultaneous heating and cooling. 2-pipe is going to be what we call a heat pump. It's kind of a bad term because everybody knows what a heat pump is, but when we say heat pump for Daikin, we're talking about single mode system. The big difference between the two of those is the third component that we're going to use on the heat recoveries, which we call a branch selector. That's kind of the squid box that directs the refrigerant each direction. So it's going to have our 3 pipes coming in. It's going to have 2 pipes going out to each fan coil. Inside of that box, each circuit has 3 expansion valves that control subcooling on that circuit or liquid and gas going to it or from it.
Oh, wow. So it has enough sensors in there to basically direct the refrigerant where it needs to go, whether it's going to be adding subcooling to it, adding superheat to it and vice versa, right?
Sort of. There's no sensors inside of it, or there's no sensors that they expose to us. Mm-hmm. Everything control based starts at the indoor unit. So the indoor unit's going to have coil sensors on the liquid side and the gas side. Mm-hmm. And depending on what mode we're in, that's kind of how the system determines what refrigerant it wants. So everything control wise starts at the indoor level. So if we're in cooling mode, we're going to communicate from the thermostat to the fan coil to the branch controller to the compressing unit to the outdoor unit. And based on that, that's where those valves and that branch selector kind of change the flow of the refrigerant where it's going. So that's where we get that term variable refrigerant flow, right? We can change the speed of the compressor, how much we have or where it's going. Sorry, go ahead.
No, one of the questions I had, since you talked about it, like you said, compressors, I've always thought are they doing just a suction control and that's what they're controlling the variable speed off of? Just they have a suction pressure set point bandwidth they're trying to maintain?
It depends on the mode of the system. So some of it will control to suction superheat or, I guess that's kind of the gist of it. Yeah, it'll control to a suction superheat, yeah.
Okay.
It gets a little bit more in depth than that, depending on how big of the system he is. So in a 3-module system with heat recovery, we have up to 6 individual outdoor coils. Mm-hmm. So it depends. Depends on how the system's laid out and what the control on the inside is doing, what we're calling for.
Okay. So with like 3 different outdoor systems, how how are they doing oil management between 3 different condensers and 3 different compressor sets? I mean, that's going to be a bit of a challenge. There's got to be some kind of oil return cycle.
Yeah. So the goal is to keep the oil in the compressors as much as possible. So we preach that there's no traps in the indoor piping. We're never going to not have traps. It's impossible. But the training and the installation manuals kind of lay it out in the matter that we avoid traps at all possible. There is an oil recovery mode. So it's time-based, and then there's some conditions for ending or starting it. With that, it's always going to be returning oil when we're in a cooling mode. Sorry. But if it sees that X amount of time has ran and there are some certain conditions, it will start an oil recovery mode. There's no sight glasses and there's no dip tubes. There's nothing to tell us there's oil there. So we just kind of have to hope that it works.
I couldn't even, how do you even start doing that? Like if you start having compressors that, start knocking out,
it's a really tough one to answer because we don't have that kind of vision into the system, right? It's kind of a black box technology to how often oil return is run. Mm-hmm. Looking at some of the service data, you can kind of peg it at about 8 hours. Every 8 hours of accumulated runtime, it's going to run an oil return.
Okay.
Now, like the oil separators and stuff, like are they just impingement type screen separators? Are they coalescence? Or are they centrifugals?
I believe they're just standard centrifugals, right? We have the discharge come in, oil settles out to the bottom.
And then is there like some kind of oil management for the compressors, like a OMB or like a fill solenoid, or is it just cap tubes bleeding into the compressor?
Cap tubes. There is a solenoid. There is an oil control solenoid, but 90% of the time it's on.
Yeah.
Really? I mean, looking at this from like our perspective, like from like a refrigeration side, this seems like a recipe for dead compressors.
Oh yeah.
It's he's not disagreeing.
No, install, because there's so much piping and so much room for error, the install really has to be perfect for it to have minimal problems. In the 8 years I've been out here, hundreds of compressors have failed. Sure, I'm not going to deny that. The systems that are installed well, far less issues. When I say well, I'm saying like care for piping practice, purging when you're brazing, straight pipes that don't wave all over the place, traps like I was mentioning earlier. Things like that really go into making sure the install is good.
So the no traps that you were talking about earlier, like I don't get that, because like the whole industry has always been like traps. I mean, with us, we're trapping every if you go up 4 feet, they want it trapped, and then they want an inverted trap just to manage oil. So I mean, obviously it's 410, and 410's almost 100% miscible with oil. So I mean, they should be able to mix. It should have way better oil carryability. Ability to carry oil back. But I mean, not having traps seems like insane.
Yes and no. It's hard for me to put in perspective because I don't do what you guys do. So I'm not totally versed on how that system works. But the less chance of a pressure drop, the more oil we're going to bring back.
Agreed. Well, I mean, most of the lines going to all these heads. I mean, what's the max size on these on the lines going out to these that you're seeing?
The biggest bore pipe you're probably going to find is 1 3/8, and that's going to be on your mains. Mm-hmm. Pushing down to fan coil level, I think the biggest is 7/8.
Yeah, so you're not really talking like really huge coils just for all that shit to lay out in.
No.
Plus if it's constantly doing, dehumidification where it could be heating and could be cooling, you have pretty good velocity going through the cooling.
Yeah.
So
velocity is generally pretty high.
Yeah.
So on the VRF stuff, like, how are they doing their compressor control? Like, is it off of suction pressure? Is it got a suction pressure set point target? Is it a temperature? Is it trying to maintain a saturation temperature, or is it some crazy algorithm where it's trying to maintain discharge, superheat, and
a little bit of both, a little bit of all. I would say superheat is probably the main control, but depending on the mode it's running in and what we're trying to achieve is going to change that. So based on the outdoor unit, right, we're depending on where we're sending that discharge gas is going to dictate what's the compressor going to do. So if we're sending the discharge gas through the outdoor coils, then back into the indoors, then yeah, we're gonna worry about that discharge. If we're just dumping that right to the indoor, then our outdoor unit expansion valve is going to control that liquid coming back so that we can then send that through the coil. Would a piping diagram help?
It would. You want to share?
Right. Yeah, I have one. Let me get the service manual open.
Okay.
And it's mostly PI controlled. They're varying. A lot of it's, like I said earlier, I hate to say it, but black box technology. We don't really get the nitty gritty of all of how it works. There's a lot of assumption in it.
That's frustrating.
It is sometimes.
Well, because like if you know how refrigeration typically works with velocities and all that other stuff, like there's that, I don't know, like actually most of it's the math and trying to figure out what the hell's wrong. This fake algorithm crap. I don't know.
It gets frustrating sometimes. All right. Is it present?
Yep, present. And then just hit share screen. Excuse me.
Oop. All right, so this is, can you say it?
Yes, sir.
This is a pretty basic line diagram of a 2-compressor heat recovery system.
Okay.
So starting from left to right, we have a suction pipe, comes in, hits the accumulator to the compressors.
Gotcha.
High pressure, low pressure. This is that third pipe I was talking about that can be discharge or secondary suction.
Okay.
Liquid is always liquid. Just depends on which way it's flowing.
Okay.
Let's get down to an even better picture. All right, so here's a broken down flow diagram. So this is a singles compressor. Let's find the dual. There it is. All right, so this is saying it's cooling operation, single or 2 compressors, single module. So you can see we have basically two suction lines coming in, hitting this one 4-way into the accumulator, into the compressors. Discharge gas is leaving the compressor, going into the outdoor coils, the upper and lower. We could talk about this one later, but it's hitting these 2 coils, shedding some heat, and then sending the liquid out to the system for regular cooling operation.
So wait a minute. There's an electronic expansion valve there.
There's electronics everywhere. Plenty of them.
What the hell is that one doing?
These ones here?
Well, I was going to say the one that's going out. I forget which line. Yeah, those ones right there.
So these ones are what control the coils.
Okay.
So you can kind of see the arrows, but it doesn't really make sense. So we have sensors on each side of the coil, entering, leaving, and expansion valves that are control those. Basic superheat across them. Same thing on the indoor, right? We're cooling mode. We're controlling the superheat at the indoor level. Doesn't show the expansion valve on the indoor unit here. But there is, I guess that's the depiction of it there. There's an expansion valve here that is controlling the superheat across that coil.
So wait a minute. What are they dropping the temperature of here off those expansion valves? Yeah, here. Like what? I don't understand. Are they just lowering, basically subcooling itself and then sending it out? Is that what they're doing there?
This is that expansion valve box I was talking, or the branch selector box I was talking about. So in cooling mode, you can see the liquid just comes basically straight through. In heating mode, we can see a difference on that.
Mm-hmm.
So they're using that tube heat exchanger to do some subcooling on the liquid. Yeah, it's nothing marked. It's nothing that we can control or see on the service tool, but there is a tube there doing some minor subcooling.
No, I mean, but those no, I'm talking about the other expansion valves down off the condenser, off the top two passes of the condenser.
These two?
Yeah.
Yeah.
Look, it's going right out the line, right out through the check valves, and then out to your liquid header here. Yep. So what? That's what I don't understand. What are they doing?
They're controlling the coil temperatures, so we can open or close in heating, or excuse me, in cooling mode. They're probably wide open, right? Because we're dumping the heat out in the outdoor section, and then we're sending that liquid straight through.
Kevin, you think they're doing almost like an HPV, where they're controlling subcooling?
Probably. I mean, they're probably making
here.
So this is a heating operation. So you can see that's reversed. Now we're controlling the expansion valve is changing the state of the refrigerant before it gets that coil. So now the outdoor section is an evaporator.
No, understood. But I'm saying in the other direction, when they're going in, where they're actually going out of the coil, they could be controlling the subcooling coming out of these condenser coils.
Yeah, definitely. There is some subcooling going on there.
Okay.
There's another tube and tube. This is an older generation. On the newer generation, they have a plate and frame doing the same process as this, is some subcooling.
Gotcha.
Well, the newer stuff, some of it's vapor injected, or it's vapor injected rolls, correct?
Yeah, definitely. So there's, I'm going to say it a lot. There's no defined sequence on the Daikin heat injection. It opens, from the best I can tell, is a low load operation. It opens to, I equate it to like an unloader. It takes some work off the scroll. Yeah, but there's nothing really says anything about it.
Well, I mean, it's basically just like we do. We use vapor injected scroll compressors too, to make the subcooler more efficient and also cool the compressors down from the heat they generate. So, I mean, we're doing basically the same thing. It lowers the intercompression ratio of the compressor too, because you have the interstage now. So it makes sense what they're doing. I mean, they're getting subcooling out of it, and they're also making the compressor more efficient.
Free work. What kind of temperatures are you looking at on your compressor's discharge and whatnot? Like, what's normal?
I mean, anywhere from 150 to probably 215 to 220, maybe 230. Depends on the scroll. With low temp 404 or 448, it's going to run hotter. I mean, you have a really high compression ratio. So, I mean, that vapor injection helps a lot. I mean, when you get that cold, you get 40-degree, vapor coming in there, or 50-degree vapor feeding that compressor. I mean, it's a big help. I mean, It runs a lot better than running liquid injection.
No, I was just trying to relate to the concepts that I know, like with what they had going there. You know what I mean?
There's a joke going around that Daikin is a liquid injected compressor because they happen to flood quite frequently.
Guess the black box technology isn't that good, is it?
It all boils down to install. For real, it really boils down to the install.
Now, with I mean, do you most of the Daikin stuff is it like I've seen like the Ys and stuff? Is it that, or is it all branch box stuff?
I'd say the most common thing that I see day in and day out is cross control wiring. And what happens there is you'll have one head calling for heating, another head calling for cooling. The wires are switched. The branch selector doesn't know any different. It's sending the refrigerant. So the coil that's calling for heat is now getting cold refrigerant, or it's getting the liquid instead of the hot gas. Mm-hmm. And that just causes a flooded condition. And that's probably the most common common thing that I see that leads to compressor failure.
So let me just make sure I understand that. So when they're utilizing heat, but utilizing the liquid for the heat, that's when you say they flood out the most.
So dual operation. So if you have say we have the smallest multi-port, we have a 4-port box. If ports A and B have their control wires switched and they're calling for opposite modes of each other, the fan coil that's calling for heat will never heat. But because it never heats, that expansion valve keeps opening, and all it's doing is just letting liquid flood right through.
Okay. I saw that they have a plate-and-plate heat exchanger in that one diagram you showed us, and I'm assuming the accumulator would have to be pretty hefty on that, right?
I think I've clocked one at like holding 30 pounds of refrigerant.
Really?
Yeah. I mean, it's about the same size as a tank.
Yeah. Huh.
But they will hold on a cool November day out here. It took 6 to 8 hours to get the last like 10 pounds out of that thing.
What?
Yeah, it took a while. It just held on to it. We heated it and it finally started coming out.
You need the big vacuum. You need the big recovery machine.
I told him to hire like the recovery service to come out here, but
you need the big old Navac machine.
What? How much?
I saw a couple. They look nice.
How much charge does that thing hold typically? I mean, I know they vary, right?
So
depending on the size.
Yeah, it depends on the size of the system, and the pipe is really what dictates the charge. So the biggest I've seen is probably about 220 total pounds, and the smallest is probably like 15 on top of the base charge, so probably about 40.
Gotcha. Do you have any explosions of the branch box that you can show me?
Not handy. I can send you one later.
Okay.
It's just some circuitry inside. There's nothing. Well, hold on. Let me look in that manual. There might be something.
It's just basically solenoids, right? For the most part, they don't actually use reversing valves in there.
No, it's all electronic expansion valves. Here we go. So the only place we have solenoids is on the outdoor units.
Okay.
And those are just changing 4 ways over. So this is a 12-port box. 10-port. Yeah, 12. So this is the largest branch selector box, 12 individual ports. So there's our connections coming in and how they filter out to each line set.
Can you zoom in a little bit?
Yeah.
All right. So electronic expansion valve, HP LP valve, and then the secondary expansion valve that's going in the suction, that's going into the high pressure low liquid. So this is only a 2-pipe system.
This would be 3.
No, 3. Oh, it is 3. Sorry, I missed that line over there. So then normal flow for this one, if we're going into heating, right? How would that flow then?
So in heating, we're coming in with our hot gas on the HPLP.
Yeah.
We're flowing into the first valve. This one will be closed. We're going into our unit on the gas side.
Okay.
The indoor coil is now a condenser.
Okay.
Back out on the liquid side.
Gotcha. And they're just go ahead.
So that's how we kind of get our heat recovery, right? So say another unit on this box needs that liquid. It's already here. So then it can come right into the liquid side, come out on the gas side.
Gotcha. So if one of these expansion valves, is bleeding by all willy-nilly, that's why you said having a clean system is important, right?
Big time.
And these aren't very large expansion valves either, right?
No, they're small. Let's see if I had one on my desk. I don't right now. Most of them are about 2,000 pulses open to close, so they're not big.
No.
What kind of valves are these? Are they 4-wire bipolar steppers? Or are they 5-wire?
5-wire. Yep, 5-wire.
So they know exactly where they are. They got the feedback signal.
I had some theories on it. I don't think they really do. They index themselves when you cycle power on things. So you can hear if you like turn the box off and turn it back on, you'll hear everything start clicking. So they do index. So I guess they do learn an open and close position, but there's doubts in my head that under normal operation they know exactly where they're at.
I see a lot of the smaller stuff, like Kevin on the liquid injection for some of the scrolls. They're using the electronic expansion valves that have the 5-wire. What is there a certain valve driver that you use for the valve for the 5-wire valves, Donald?
So, yeah, I'm partial to one called the EEV Mate.
Yeah, I see that guys selling those.
Yep.
Yeah, so somebody basically made it, Brad. They took a Raspberry Pi and like literally made their own stepper valve driver, the little tiny stepper valve driver box.
It works great. The only downside is you don't have feedback from where the valve was originally, so it's good practice to. On Daikin, we have something called recovery mode, which opens the valves fully. So it's good practice to do that and then use the tool and then drive the valve all the way back open when you're done.
What did you call it? EEV what?
Mate, M-A-T-E.
Buddy, EEV, buddy. EEV. Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. Damn. Okay.
Yeah, it's pretty slick. Handheld, power with a 9-volt.
I think I've seen this when it was on, because he was on Kickstarter or somewhere. I thought I saw something like this.
I don't know if he did, but there's a couple that pop up. There's VRF Tools has some. There's a guy that just posted recently about making his own. But Kevin's been making this for a couple of years, and it's pretty solid.
Good deal. So all right. So the indoor unit has up to it has two expansion valves or 3 expansion valves?
One.
Two.
Just one. There's, I think some Mitsubishis have 2, but all the Daikin units have 1.
Well, the one you just showed me. Showed me.
This is a branch selector box.
Oh, okay.
That 12-port. I don't know if there's a breakdown of the fan coils on here.
I'm assuming it comes at like a 3-way valve. The switch from hot gas to liquid flow. They're probably using the EEVs. That way they can mix it. Does that sound kind of correct?
No, we're not mixing in the box. Mitsubishi does, I believe, but Daikin does not. So This is the single port box. We're coming in liquid. We are doing some subcooling here, but if the fan coil is calling for cooling, we're not going to open this high pressure, low pressure if it's in parallel operation. So if we have multiple fan coils, one's in heat, one's in cool, this one should be closed.
Okay, so the branch box has 3 different electronic expansion valves.
Correct.
Okay, and so I guess the Okay, and then the regular unit you said would have just one expansion valve for the refrigerant going through.
Yep.
And it's going to decide if it's going to open up all the way or adjust superheat or whatever, because it looks like you have sensors all over this thing.
So there's an air sensor, there's a liquid sensor, and a gas sensor, or liquid and gas.
So by that right there, they can tell about how much superheat they have.
Yeah, that's a bad example too. That's a very specialized indoor unit.
No, that's fine. It's still showing. It's
normal.
Still showing the principle, though, right?
Yeah. So we have our cooling mode liquid coming in, hits our expansion valve. We have our liquid sensor, the distributor to the coil, a gas sensor on the outlet. So based on these two sensors, we can get the superheat across this coil.
Gotcha. Well, I see filters all over the place. Please tell me these are serviceable filters.
They are not.
By your chuckling, I'm going to say they're not.
How good are you? They do sell replacement parts, but it's really tight inside there. Most of the time, it's just going to be remove and replace.
Shit.
Like the whole branch box?
There's no serviceable components in the branch box. It's filled with expanding foam, so there's nothing inside here you can change. You can pop the heads off, but you can't get inside the box.
So say you had a branch box, say with like 5 or 6 circuits on there, one valve fails, you got to change the whole branch box?
Yes. But to that point, in 8 years, I've seen one box have a internal failure, and I'm pretty sure it was because it was dropped.
And for the most part, it's just controlling flow, right? So it's either opening or closing. You know what I mean?
Yep.
There's no temperature sensors or anything in there. It's just, either opening up all the way. So it's not like an electronic expansion valve where you're cycling, all the time. And right. Sometimes when it's cycling for heat, it's just going to stay fucking heat all year round then, potentially.
Right.
Okay.
So this valve here is the one that gets the workout. This one will change to maintain that superheat.
Gotcha.
But inside these units, they're pretty basic. Right? We got a fan, a heat exchanger, some sensors, an expansion valve. There's a whole litany of different style of fan coils. The most common is going to be this one here. This is the FXMQ pancake ducted unit. Fits in your ceiling.
Oh, the one like in the ceiling grid there?
The ceiling grid ones are going to be the ZQ and FQ. So okay. This is the 2x2, and then the FQ, similar design. It's just bigger, 3x3 square.
Gotcha. So now we know how this is run. How about the condenser? What are we doing there? As far as how are we controlling off of head pressure? I mean, I saw those 2 valves over there, which could be used for subcooling, but what are you trying to maintain throughout the year? Is it always the same pressure, same temperature? What are you guys trying to do?
So it depends on the mode you're in. It spits out something called the targets. So the condenser has a section of memory that is set during initial commissioning that dictates what we call the targets. So it's trying to maintain a high pressure in heating and a lower pressure in cooling. And depending on what ratio of indoor and outdoor are running heating cool, or excuse me, the indoor units are running heating cool, those targets are going to change. So that's where the variable technology comes in. So if we have 50-50 load indoors, the compressor isn't going to work as hard because we can then recycle that refrigerant. If we have 100% heating indoor, compressor is obviously going to run harder. Our target's going to be higher.
So yeah, how does that work with if you are running 50-50? Then the compressor is not doing as much cycling. I mean, because the compressor all it's doing is cycling the refrigerant around, right?
It's just a pump, right?
Yeah.
Let me see if I can pull up the chart to kind of make it more sense. Service manuals are really long. The compressor is going to do what it can to maintain the call indoor. 50% load is probably going to push into cooling control. and then the heating units are going to suffer a little bit, but not crazy. So I'm going to share the air quotes basic operation.
Okay.
So normal cooling, we're doing PI control, high pressure control,
Zoom in just
or low pressure.
Zoom in just a little bit more, Don.
So yeah, outdoor fans will ramp up and down.
When it's in cooling mode?
The fans will change speed in either mode. They're the inverter driven fans. I've seen out here, I mean, I have it super lucky out here where it's like perfect conditions all the time, but there's certain days where the condenser fans won't run at all, and people are very confused on, you know, I don't have any fans running. It was like, it doesn't need to.
Mm-hmm.
It's dumping or picking up as much heat as it needs.
Well, all right. So, service question. Let me ask you: how would you figure out if your pressure is running obscenely too low for what the machine is actually made for? We got to be maintaining some sort of head pressure somewhere, right? So, what is telling that fan to ramp up and ramp down?
The condenser temperatures, or the outdoor coil section temperatures.
So there's no pressure transducers on this at all.
There are pressure transducers, sure.
Okay.
But if we're getting to I guess I'm not clear on the question. So a low pressure condition,
the fans would basically start shutting down.
Yeah.
Right.
It's probably going to trip an error well before it starts running, though. So if we're fighting a leak, it's probably going to trip an error code before it starts running the fans and the compressors, full bore.
Okay.
There are certain situations where it won't trip like a low pressure code. The low pressure code is like U0, or it's shortage of refrigerant. And like that code is kind of the kiss of death, where if you see that, it's probably too late.
What, for the compressor?
Yeah.
Because it's already overheated itself to death, or what?
Yeah. So that's kind of why I asked what typical temperatures you guys see is normal. The red flags in my head start shooting up when I see discharge gas of like 175 degrees.
See, we're usually, we are monitoring that to make sure, our discharge superheat doesn't get up too high, especially with some of the other refrigerants that have a higher compression ratio, because you start generating more heat, right?
Yeah.
But for the most part, I'm looking at pressures and just trying to correlate it. So like every single one of our condensers has a TD, right? So if it's 100 degrees outside and it's 10 degrees outside, my saturated condensing temperature should be about 110 degrees, right? Because you can't get higher, you can't get lower than the ambient, right? And then making sure you getting at least anywhere from 3 to 4 or 3 to 5 degrees of subcooling out the drain leg. And if I'm getting all those, then I'm fine. But what I'm saying is, your pressure is obviously going to change for however hot it is outside, right?
Right.
Like for the most part, we're just looking for the TD control. We're not looking at all that other stuff, but that's, I didn't know if, I'm assuming since they have sensors all over this place, they're constantly maintaining what's coming out of that condenser, what's going in that condenser, right?
To the best of its ability, yeah. If it's short on gas, you're going to start seeing discharge superheat climbing. We have a broad range, well, at least Daikin does, of like 27 to 82 degrees of discharge superheat. So as long as it's within that range, we can say it's probably okay. As soon as we start approaching 80, 85, 90, we're probably looking at a low refrigerant charge situation.
So they're dependent on, go ahead.
These systems, I couldn't really see that condenser piping diagram when you had it up, but I've seen a couple other systems. Don't some of these systems have a receiver?
Mm-hmm. Yeah.
So if you have a receiver, couldn't they just monitor the receiver level and do charge protection that way instead of just worrying about discharge superheat? It seems like it's a seems like it's a fatal flaw there. If you get, I'm assuming it has no sight glass, no receiver level indicator.
Nothing.
So you have no idea if there's anything in there.
Correct.
Boy, that makes it.
If I had my way, then there's tons of modifications that I would do to one of these systems to make it better. But this fits the mold for 85% of the jobs.
Seems like it's very difficult to troubleshoot that at that point. Like you're kind of, your hands are tied behind your back almost.
To a degree, yeah. The service tool does give you a lot of information. And like I said at the beginning, it's really just going back to the basics.
The service tool, is that the program you use to connect to the Daikin's?
Yeah, it's called a service checker.
Okay.
Just plugs in on the same communication line and gives you all the information, all of the sensor values in the outdoor unit, the indoor unit temperatures, valve positions. The only thing it doesn't give you is branch selector information.
So how do you know what the branch box is supposed to be doing then?
Hoping and pray that if it's in heat, you get heat. If it's in cool, you get cool.
And that gets that signal from each fan box out at each room, right?
Yeah.
Yeah, because that's gonna tell it what flow to have, right?
Correct. Yep. That's gonna basically control that expansion valve where there was two kind of stacked on each other.
Yeah.
Whether we open the suction valve or the high pressure, low pressure.
Yeah, but they're basically just opening up or closing. There's no real modulation going on with those.
Don't know. Nothing's published about it. So I know Fujitsu uses solenoids in their boxes that just open and close. So I imagine Daikin is similar. Might be easier and cheaper to use, a 12-volt stepper rather than a line volt solenoid.
Probably get more cycles out of it too, right? Because it's a solid state device.
Yep.
Huh. I'm still perplexed.
It's a lot to wrap around your head.
Well, it seems like there's not that would drive me nuts not being able to have like shit explained to me. You know what I mean? Like, oh, well, it's the magic that goes inside there. I'm like, that doesn't make any sense.
It's troublesome, but the more you look at it, the more you kind of understand what's normal operation, and then certain things pop out and it is abnormal. Like I said, like when I see compressor discharge temperatures like 175, that's when I start really paying attention, drilling down, trying to figure out where there's an issue.
So your normal discharge temperature is how much?
Our discharge superheat has a range of 27 to 82 degrees. So depending on those targets I was talking about earlier, we could be anywhere from like 114 discharge temperature to like 165, 170.
Yeah.
I mean, 170 discharge temps for us are phenomenal.
That's awesome. That's like winter temperatures.
Yeah, for us, like 170 discharge temp, that's a happy compressor.
I like seeing about 165, 155 in that range, just because it's kind of smack in the middle.
Well, he doesn't have the compression ratios, right?
Our compressors are smaller than yours.
We have some super small scrolls too. Like a lot of basically to me, like VRF looks exactly like a protocol, like which would be it's literally a scroll mini rack. I mean,
so there's some similarities.
Yeah, there definitely seems to be some similarities to it, like a lot of them.
Do any of your guys' products have variable speed compressors?
Oh yeah, everything new does.
And they're all on drives, or do they have inverters yet?
Most of them are on drives or digitals. Not too much like inverted compressor, like no DC driven compressors yet, but like it's pretty much everything new is on drives or digitals.
Yeah.
Yeah, they're just using suction blocking for the unloading, except for with the scrolls, you can do it from like 10 all the way up to 90%. Or I'm sorry, 10 to 100%. So you have that full capacity of that range. So if you have some kind of oil management system, shit, you could have two in place where basically one runs, and then if it loads that one up to 100%, it can kick the other one on, and then load that one down to whatever you're trying to maintain. Because your stuff, you're trying to maintain what, 38 degree coil, 36 degree coil.
It varies. 40 in cooling mode, evaporator temp about 43 is like, perfect, ideal, great. It's going to cool well. But it varies. Like today, the unit I was working on, the evap temp was targeting 28 degrees. But it was driving, balls to the wall cooling.
Oh, okay.
Changed some settings. It jumped up to about 37 and found its happy medium. But it varies. So there's specific settings in the condensers where we can tell it to target different temperatures. Out of the box, the new VRV4 has this, they call it VRT, variable refrigerant temperature. If we needed any more acronyms. And it basically looks at the ambient conditions of the indoor and outdoor and makes an on-the-fly call to whether or not it needs to change those targets higher or lower. So the perfect example where this doesn't work is retirement facilities where when they want heat, they want heat.
Mm-hmm.
So if it's, our units lock out mechanical heating about 75 degrees ambient outdoor. If it's like 73 outside and somebody puts it in heat and VRT is enabled, they're not going to get 114 degree discharge air. They're going to get about 85, 90.
So it sounds like in that option where they're doing what I talked about, where they're floating the head down as the ambient goes down.
Yeah, for sure.
Which makes sense because like they do that for supermarkets. Some of the older supermarkets also have the heat reclaim coils, and they have the heat reclaim bypass valve, so that basically they can bypass what in turn would be a holdback valve to raise the pressure up, like in wintertime, because that would be the most expensive type of heat, right? Yeah, because you're basically raising the compression ratio, which is raising the amount of kW used. Yep.
So that's the whole goal of VRF, is to reduce the electrical draw, reduce the kW.
Well, I'm out of questions. Kev, you got anything?
No, I think it's a good basic one. I mean, the first one, I mean, we should definitely do another one, like more in depth, like breaking down the piping and every single part of it.
You touched on a good point about the DC driven components, and that's what we see people get tripped on a lot too. Is it's still an AC motor, but we're pulse width modulating DC to mimic a AC sine wave. So that trips people out all the time.
No,
you guys get a lot of electrical part failures, like boards and.
If you know anything about Northern California, our power grid is junk. During the summertime, our utility floats the carrier voltage about 500 to 505 volts.
Ooh.
Our machines are 460, rated 460, 10% tolerance. So we're at or above tolerance for most of the summer. And yeah, they call it a thermal event. It's not an explosion. It's a thermal event. But yeah, we have significant electrical failures, seasonal changeover. When we go to the first part of the heating season, everything kind of hits the wall, and then back into summer.
Oh, because there's not that much draw on the grid. So when there's not that much draw on the grid, all the voltages go up, and then all of a sudden, boom, thermal event.
Yep. Or if we're in, Northern California industrial areas, when large rotating loads come online.
What?
Same thing. There's a couple turbine plants that blew up some equipment. Data centers have issues with it too. When they do generator changeovers or they do testing, a lot of the power is weird out here. So there's a lot of places that have phase converters still, and the belt-driven phase converters tend to be issues too.
Come on.
Well, that green energy is not really working out.
It's such a joke.
How's California's grid doing on all the new Tesla chargers out there, huh?
Oh gosh, I have no idea how that's going to work in the next 4 years. It's like I have an apartment, and I'll be damned if my rent's going up $500 so somebody can charge their Tesla.
Yeah, I live in Indiana where we get that nice coal-fired power that works.
Yeah,
we still have coal power in Texas too. It just doesn't work when the piles freeze because they don't plan on it. So that's what happened last power outage. I guess all the coal piles they couldn't move them, and then the natural gas, because if you have natural gas running outside, it needs to be dry natural gas. So they usually run it through air dryers to get the water content out. Oh fuck! Why do we need to do that? It's only going to be like 20 degrees in Texas for 2 days. A couple days later,
like every other state does.
Well, they don't think they have to because it never gets that cold here, Kevin.
It snowed, and you people can't drive with like a quarter inch of snow on the roads.
I am an implant, sir. I can still drive.
Yeah, I'm not afraid of rain or snow. I came from Pennsylvania.
Yeah, I'm surprised you're in Cali.
I fear the day that it snows here in Northern California. It's going to be like, we joked about on the East Coast, like snowpocalypse when we had blizzards. It will be an apocalypse out here.
Oh, dude, Texas was broken.
That's how Texas was. There was
last year
trapping a highway for days
with the dusting.
Dude, it was busted. And someone was like texting me, was like, "How's Texas right now?" I'm like, "I'm fine. I still have my power." And they're like, "What?" I was like, I must be on the fire department's grid, so I still had power.
Yeah. Anywhere I live, I try to live near to a hospital.
Smart man.
Well, Brett lied to you. He's one of them fancy people. He's got one of those 25 kW gas-driven generators.
Get the fuck out of here!
Big old Generac out back.
He's got a Generac out back. They'll let him fool you with a heated pool.
I've been in some custom homes that had V6 twin turbo natural gas generators in the basement.
Damn,
It was wild.
Everybody by me has a Generac except for me.
That's only because you're fucking cheap.
Yep.
All right, Donald. Hey, man, thanks for coming on. I really appreciate it.
Thank you, guys.